All right, welcome back. Before we move on to finding the sum of a finite geometric sequence, I thought that I would do one more example, how I ended the last video on writing the rule of a geometric sequence given any two terms. So I'm given I have a geometric sequence, I can write the rule for the sequence if I'm given any two terms in the sequence by solving a system of equations. I thought it might be helpful to do another one of those examples. So I'm going to start with the example, geometric sequence. The two terms I know are a3 equals 20 and a6 equals negative 160. So I'm going to solve the system of equations by plugging into my formula. So a3 equals a1 times r to the 3 minus 1, or 20 equals a1 times r squared. Over here, I can say a6 equals a1 to the r 6 minus 1. I can plug in a negative 160 for a6. So I get negative 160 equals a1 times r to the 5th. I'm going to go back to my first equation here and solve for a1. So I get a1 equals 20 over r squared. I'm going to go and substitute that in here. So I get negative 160 equals 20 over r squared times r to the 5th. I can cancel out this r squared with this r to the 5th and be left with r cubed. So I have negative 160 times 20 r cubed. Divide both sides by 20. I get r cubed equals negative 8. So r equals negative 2. Now that I have r equaled negative 2, I can come back here and find a1, 20 over negative 2 squared, or 20 over 4, which is 5. All right, so if I want to come back up here and write my rule for the general case, I would have an equals, from down here, a1 is positive 5. R was negative 2, make sure this is in parentheses, n minus 1. All right. Given this formula now, I can plug in 1 and get the first term. I can plug in 2 and get the second term. I can plug in 3 and get, well, you know what 3 is, and keep going. We're going to move on, and we're going to talk about geometric series. So again, a geometric series is just when the terms of the sequence have a plus sign in between them. So an example of a geometric series would be something like 2 plus 4 plus 8 plus 16. Or another example, it could be written in summation notation. K equals 1 to 10 of 4 times 3 to the k minus 1. Again, to get from here to some sort of sequence like this, I just plug in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we want to find the sum. Now we cannot always find the sum of an infinite geometric sequence. If you think about that, it's going to be going to get bigger and bigger and bigger and bigger. So we can't do that. But if it's finite, meaning that it only has 10 terms, then I can find the sum of it. All right, so to do that, we are going to use the formula the sum of the first n terms of a geometric series is a1 times 1 minus r to the n over 1 minus r. All right, where a1 is the first term and r is the common ratio. All right, so in order to find this sum, the things we need to know are the first term, and we need to know the common ratio. All right, so from this formula right here, if I plug in 1, I will find the first term. So a sub 1 is going to equal 4 times 3 to the 1 minus 1, which is equal to 4 times 3 to the 0 power, which is 4 times 1, or 4. So my first term is 4. And I'm going to teach you 2 ways to find r. One is a shortcut. The thing in parentheses raised to the k minus 1 power we always know is r from our formula. So here I know r is 3. Another way I could do it is find a sub 2 and then do the ratio of a sub 2 to a sub 1, and then I would have the common ratio as well. But we're going to use the shortcut, knowing that this is going to be our common ratio. All right, so I know my first term, I know my common ratio, so now I can plug into this sum formula, the sum of sub 10, which means the sum of the first 10 terms. I get that from here, is a1, which is 4, times 1 minus 3 to the 10th over 1 minus 3. All right, I don't expect you to do that in your heads. You're going to go ahead and you're going to put that in your calculator, and you're going to get 118,096. All right. All right, let's do another example. All right, so here I would want to find the sum of the first 6 terms from 1 to 6. Okay, so I need to know a1 and I need to know r. My quick trick here is r is 5, a1 is 1/2, 5 to the 1 minus 1, because I'm plugging in 1 for k. So I'm just going to get 1/2 times 5 to the 0, which is 1/2 times 1, which is 1/2. All right, so now given a1 and given r, I'm going to plug into my sum formula. So the sum of the first 6 terms is 1/2 times 1 minus 5 to the 6th over 1 minus 5. Again, if I plug that into my calculator, I get 1,953. All right. Let's attempt to do your worksheet. Reach out to me, Zoom me. I can do a Google Hangout. I can do a chat if you have any questions, okay? Have a great weekend. Bye.